Hi. In this particular video, I will be sharing with you how to calculate the expectations and the standard deviations for a discrete uniform model, as well as probabilities. So let's begin by going to our whiteboard. And you may recall that in an earlier video, we saw this particular whiteboard where we were doing the math for a custom probability model. So now what I'm going to do is I'm going to build a second model called a discrete uniform model. For a random variable. In a discrete uniform model, what characterizes your situation is the following. So I'm going to imagine that you're looking at a call center. Receives anywhere from 0 to 6 phone calls per hour per staff member. Each of these outcomes occur with equal probability. That's what a uniform model is. A model in which every possible outcome on the list of outcomes has an equal probability. And so first step, construct the model. Second step, find the mean and the standard deviation of the model. So what we do in this situation is one of two things. First, let's build a model. Zero, 1, 2, 3, 4, 5, 6. This is a tricky model because, as you can tell, 0 is a possibility. It could be that the staff member is completely unoccupied by the phone for a whole hour, or it could be that it's 1 call, 2, 3, 4, 5, 6 calls. So this, in effect, is a 1 out of 7 probability for each instance. Okay. Not 1 out of 6, but 1 out of 7. So if you had a problem such as what is the probability that a staff member receives more than 3 calls in 1 hour, and usually you would say 1 randomly selected hour. So then for part, so this is for part 1 here. Part 3, you would have the probability that x is greater than 3. That's how you would write that. It would be the probability that x is 4 or 5 or 6. So it's in all 3 out of 7 possibilities. That's how you would answer part 3. And then to answer part 2, you would go to Stat, Calculators, Custom. And in Stat Calculator's custom, you would enter that the values are in X, that the weights are in P, and then you would click on compute and you'd get the answer. So let's go do that. Back here to StatCrunch. Instead of X being 0 to 3, I'm going to say this is 0, 1, 2, 3, 4, 5, 6. And then the probabilities are not going to be so I have to figure out what 1 in 7 is. I'm going to go data, compute, expression, and I'm going to divide 1 by 7. And I'm going to take that 1 by 7 and paste it in every one of these so that I get a probability value of 1 in 7 in each case. And then I'm going to go into the custom calculator that I had used in the video for the custom computation. And I'm going to go options, edit, and recompute, because everything else is already preset properly. And I can now look at the probability that X is more than 3, and that's a 0.4285, which consists of these 3 red bars out of the 7 bars. The mean is 3 calls per hour, give or take 2 calls per hour. So in this case, the mean and the standard deviation are 3 and 2. So if I had to create an answer for these, then I would just go and see that the expected value of X is 3 calls per hour per staff member. And that then the standard deviation of X would be equal to 2 calls per hour per staff member. And that solves pretty much any kind of question from a discrete uniform model. Any question about a probability model itself, any question about the expectations and the deviations in the model, and any probability specific to any interest we might have of a situation that we call a discrete model of probability, a discrete uniform model of probability. It's a model where all random variable values of X have an equal probability. And of course, the sum of all these probabilities must add up to 1. So that's what we call a discrete uniform model of probability. Thank you for watching this video, and I hope that it is useful at completing all your lab and quiz and exam 3 activities, but also that it is helpful at understanding how to treat situations where different values with equal probability can be the uncertainty surrounding that can be measured. Expectations, deviations, and probabilities, the 3 metrics of uncertainty.